All right, this is area of composite figures. How can you find the area of shapes that are not just one standard shape? Okay, that's our central question. Let's go ahead and start. Composite figure. It's made up of two or more shapes. Okay, and when we talk about shapes, we're talking about the ones you're accustomed to: circles, squares, triangles, other parallelograms, trapezoids, things of that nature. So let's recall all the area formulas that we know of so far. So we've got a parallelogram. That's base times height. The height is not the slant height, but it's the perpendicular height, right? The height that goes from the base straight up. Okay. Next, we have a triangle. Same is true. It's 1/2 base times height. Remember, we talked about a triangle is just half of a parallelogram, right? If I were to draw another triangle right here, the same shape, just flipped it over, I would have a parallelogram. And so therefore, it's still going to be base times height, right? The height is 90 degrees. It's just half of it. Trapezoid. We talked about a trapezoid yesterday, and we derived that information. Again, if I were to take a trapezoid and I take the same exact trapezoid but flip it over, I end up with a parallelogram, which means on a parallelogram I find the height and I times it by the base. In other words, this base here, though, is different size bases, right? This was base 1, base 2. Well, down over here now, this is base 2 and this is base 1. So all this across are these two added together. But remember, I don't want both. I just want half of that. So that's why it's half of base 1 plus base 2 times your height. And then, of course, we have our circle. Area equals pi r squared. Okay, so let's take a look at our first example. Laura's father is building a shed. How many square feet of wood are needed to build the back of the shed shown here? So this is the shed. Take a moment to go ahead and draw that picture. And this is the back part of the shed. We know that it's 15 feet across, 12 feet high, and that the roof part is 4 feet of an inclination right here. From here to here is 4 feet. So let's think about it. We can cut the composite figure into easier parts. Now remember, the word composite means more than one shape. Like a composition, you're putting things together. A compound sentence, you're putting sentences together. Same thing here. Composite shape means that really this is kind of cut up into a rectangle, parallelogram, if you will, of 15 feet across and 12 feet high. And then the triangle that's sitting on top of it, that's also 15 feet across for its base, but is 4 feet high. Okay, great. And so I'm going to figure out the area of the triangle first. Area of the triangle is half base times height. I do the calculations, I get 30 feet squared. Then I do the parallelogram or rectangle. That's just base times height, which is 180 feet squared. Lastly, I just add those together. So 30 plus 180 is 210 feet squared. So that is the total area that needs to be covered by the wood. All right, so next example, the basketball gym floor needs a new paint. Find out how many square feet is needed for this portion. Okay, so these are the measurements that I know. I know it's 12 feet right here, 19 feet from here to here, and that's all I know. Okay, so once again, I'm going to break this up. I know that I have a parallelogram, which is right here, this rectangle, and I have a semicircle. A semicircle, remember, is just half of a circle. So if I were to complete this, I would have a circle here, but only have half of it. So here's what we do. We're going to split up those shapes. I have a parallelogram here, and I have a semicircle here. The semicircle, I know its diameter. I knew that from here to here across, which is the same over here, is 12 feet. So that's what I drew over here. So let's go and figure out both. I wrote both of them for you here. The area of this parallelogram is just base times height, so that's 228 feet squared. And then the area, well, if I know that of the circle, if I know that the diameter is 12, I know then the radius is half of that, which is 6. Plug it into my formula for area of a circle, and I find out that I get, I might have done something wrong here now that I notice. I'm going to do 6 squared, 6 times 6, times it by pi, 3.14. I end up with 113.04. But I see something wrong right here. What did I forget to do that would make this incorrect? Well, I forgot that this is a semicircle, so I need to also divide it by 2. I only want half of that, so that ends up being 5652 feet squared for that semicircle. So that means this is going to be incorrect. And I add my 228 with my 56.52, and I should end up with the correct approximate answer of 284.52 square feet. Again, it's an approximate answer because of the pi right here. This right here, as soon as we approximated pi to be 3.14, we knew that the rest of the answer is going to be approximation. It's going to be close to it and close enough. All right, and we come to our last example for today. Michael drew his design. Find the area of the shaded region. So here's his design. Pretty simple, but I just want to know the area of the red part and not the little extra parts. So what I notice here is I find the area of the entire parallelogram, right? So I'm going to go base times height, 15 times 12, that's 60 square inches. Okay. Next, what I want to do is I want to find the area of the small triangles. Okay. Area of the small triangles. You see these little triangles here, these 4? They're all the same measurements. It looks like they're 1 by 1. The base is 1, the height is 1. So the area of one of the little triangles is going to be 0.5. Okay, half of an inch. Half of a square inch, I should say. But I have 4 of them, right? Because I have 4 corners. 1, 2, 3, 4. So multiply by 4, I get 2 square inches. So my final answer is to then subtract those. I'm going to take the area of the parallelogram, subtract the area of the 4 little triangles, and I end up with the shaded area. All right, that's it for the notes today. Be ready for classwork tomorrow.